How's it going, everyone? Welcome to another video on the front-end system design. This is a course taught by Evgeny Ray, this software engineer, Ukrainian software engineer that has previously worked at JetBrains for over 3 years and now at Meta. And thanks to him that he made this particular course as a way to recap the fundamentals of system design for UI engineers specialists. All right, why is that? Because knowing the foundation of this will help us to now actually solve what the client's problems or what the business problem is, which is usually, as a UI specialist, is to build now this user interface, complex, large user interface as your application scale and that kind of thing. So by understanding this fundamental of the system designs, we're going to gain now is this perspective, this experience, thanks to Evgeny Ray, and also is the terminology, all of the basic building block, as well as how we're going to put that at practice as a way to now come up with a solution, and then ultimately we can actually do what we need to do, which is build the UI and also take ownership of that. So because of that, all right, in today's video we're gonna take a look now is at the DOM API. We're gonna make a quick recap over the core fundamentals, okay, and understand now what is the roadmap of this course. Okay, so the roadmap for this course is, as I mentioned, as I put it here, this introduction as a way to know why we do the thing that we do, and understand that as a way to move on to the core fundamentals, especially as a way to build now UI on the browser, the DOM API. How can we now come up with some complex UI patterns, and what are the now new APIs that allow us to use or to create this more complex pattern? The virtualization is one of the most frequent of all of that, as a way to show only the necessary elements per viewport. So as the user screen, you're going to now display all of these elements in real time. Also, how you can now is store and manage the states. So how you can now in an efficient way put all of this data in all of this bucket, right? Or you now allocate all of this data and research in memory as a way to say, hey, all right, how can we do that, or how can we manage and store this data in the most performant way possible? There is something called normalizer, which is part of the Redux community. Actually move away from that in favor of something called relay. Okay, as relay, my bad, this, all right, which is also something from Meta. Okay, the GraphQL client that scale with you. Well, where the idea here is to actually is now remember, at the end of the day, all of this top tech company, the problem that they are facing is scalability, and scalability is not a child's game, and it's also interesting, by the way. So yeah, so this client GraphQL allow you to now is keep management of data fetching easy, whether your app has tens, hundreds, or thousands of components. And thanks to the Relay incremental compiler, it gives you iteration speed fast, even as your app grows. There are actually people who are now the maintainer of Redux that actually are working in Relay. So you can start to see what is the challenge that this particular company actually are doing after all. So, because what we really care about after that is look at how you can organize, how can you store and manage your data in the most effective way, understand how you can communicate from the client to the server, what is the protocol of that you can use that, whether it is an HTTP or WebSocket or server-side event, all right? How you can now is optimize your UI by managing all of these assets, JavaScript, HTML, CSS, image, fonts, you name it, okay? And last but not least is that a way of how can we actually put all of those concepts together, so we to build and design a very simple and common application like social media app. So the introduction of all of this is to see hey, what is an application is made of. So you have now the front end, the API, and the back end according to the IFNI. In our particular case, we're gonna focus is on the front end, all right? And I see that there is a demand for people who, the demand right now is not only on the front end as a way to provide a good experience for that, but also the demand is for data management. Why I mentioned that? Because a lot of job posts out there actually are now using is or they need to actually know how you can actually come up with a solution when it comes to manage data or to scale data, all right? That's when now knowing about that structure, algorithm, and some performance techniques is more important than ever, right? Because you want to get now a result pretty fast if you query data not only to our database or to or to any data set. And this is where the value it is, the vast majority of this company. But in any case, here we're talking about is the UI, because this is where my experience lies. This is where my strong suit over the past couple of years is. And yeah, so this front end layer of the applications, okay, part of the design system. It's made of the how you can communicate with the application. So all of these big buckets, okay. So how you communicate with the application, how you can now manage the data once you get that from the server, how you store it and manage in an efficient way, and then how you can now with that data use that to show some UI pattern as a way to work with most common UI patterns. So how you're going to present this data to the user, for example, when you have thousands of records in a small screen, right? And what are the most common UI pattern that we can use, as well as the API. And last but not least is how can we now organize all of our assets again in the most effective and efficient way. So this is now the core structure, right? And if we want to understand now the core concept of the core fundamentals, again, I'm gonna make a quick recap because what I care in today's video is to the DOM API. So this core concept is as a way to now become you a Reflow master or a Reflow Jedi. What is Reflow? Let's go to start from the beginning. Because on the browser, especially on CSS, everything has a box around it. So, and they use this to now tell the browser so when you understand this particular mental model of the box, allow you to now build more complex UIs, which is what we care about. So for that, we need to understand is the box model, the box anatomy, what is the component of that, the content, the padding, the border, and the margin. All right, what are the properties of these boxes, whether it's by the size or by the type. So by size you have now intrinsic or restricted, and then intrinsic is that, well, it is content. It'll be determined by its intrinsic values, by the height and the width of this box, the content you put inside of this box, using HTML tags. And the other is restrict. So here there is some couple rules that you're going to apply to this particular HTML elements that the browser applied to this, as a way to now apply the size, or determine the size of this box. So for example, whether it's you use an aspect ratio, or the size of this will be determined by the percentage of the pattern element, as well as this width and height. And also we have now the type of box. So how now the browser treats the HTMLs here, right? So we have now inline, we have blocks, and we have anonymous. So most of the time anonymous is something that you don't actually care about. But what happens is that those content that you don't define inside of HTML tag, the browser put a box around it. The most common are block and inline. And how, when you have this type of box, okay, each one of them is something called a formatting context. So the block, create a block, followed by its rules, which is, it's gonna take this element block, is gonna take all the width. We're gonna take the 100% width of the padding element, and it's gonna put all of these elements, and it's gonna position all of these elements from top to bottom. All right. There's some mathematics associated with that. As a way to calculate is the size of this block elements, as a way to also work with the geometry of the boxes. All right. And how we use is some property called box sizing, as a way to say, hey, let's going to make our life much more easy when it comes to calculate if, for example, the size or the width of the type block element, that it can be, for example, an anchor tag or a div, a section, h1. This is the most common HTML tags. And then you have the inline elements. So here in inline elements, again, it creates now another formatting context, an inline formatting context, that elements are now rendering as a string, right? So from right to left, or from your perspective, from right to left, okay? And the inline elements here, they have some couple rules as well. So for example, width and height are not affected by this type of elements. Even the same for vertical line. And if you add some padding to that, it doesn't alter is the height of the inline elements. So the content is there. What it's going to do is to expand or get out of the particular inline, or it is borders. So why are we looking at this type of block? Because each one of them creates a particular context, and this context, the benefit of the key feature of knowing this is that it allows us to know, or for the browser perspective and for ourselves, is to isolate this series of elements that entering in this particular formatting context. It is scalable, which means that this formatting context can not only be is a flex, or can not only be is a block or inline flex, but also can be a grid or any other formatting context that in the future we want to add to this. And also it make it predictable, because once you know the rule of this formatting context, the elements you put in there it's going to behave according to this rule. So the idea of that is that once you are able to understand that, we make a quick exercise, a way to see how the formatting context is created, and then now understand how the browser position elements, which is something that they call is normal flow, okay, where you put all of these elements from left to right and then top to bottom, right? If you use, for example, a property in CSS called position, you're going to change the normal flow. Therefore, you're going to create now something called a stacking context. This stacking context, which when you use a static, this is the part of the normal flow of how the browser position elements. Okay, so when you use, for example, position relative or absolute, but in this case relative, so what you're telling to this HTML tag, hey, I want you to now is all of the children elements that you have inside of that create now an stacking context. So properties like top right, bottom left will be applied to this element. It will not interfere with other elements. So when you offset that relative element, it's not going to it's not going to take space from other components. And the reason for that is because you create now a new stacking context. So this position relative act as a containing block, all right, for other type of stacking context, which is position absolute. So when you have now the position absolute, all right, there's some rules that apply here, and that is, well, the content. So this element, of course, is removed from the normal flow. The space is removed. So there is no space reserved for these elements, or all the elements defined inside of this element that use position absolute. Okay, and this position absolute is gonna anchor itself to the position relative, to the closest position relative, if you define that, or to the initial containing block, which is the HTML, right? Top right, bottom left values determine the position of these elements, and you're creating is this new stacking context by using is now position relative. But again, the summary of knowing that the stacking context is being created is because, well, the benefits of knowing is the formatting context and the browser positioning, or in this case the stacking context, is that you can now isolate all of these elements and also apply some performance optimization, or you can apply some optimization to these elements inside of this stacking context, especially elements. So for example, when you're using now a 3D transformation or an absolute position or anything that make or that moves the elements out of the normal flow, it create an effective stacking context. Yeah, it create an effective stacking context. So with that, all right, the idea of knowing is this stacking context, or the value proposition of this stacking context, is that now you can create all of these layers, okay, and each one of these layers you can apply now is some performance optimizations using, for example, CSS transition, that when you use that, depend of the CSS transition that you use that, or depending of the CSS that you apply to these elements, it's going to now trigger is a reflow. and you don't want to trigger too much reflow. And what is reflow? Glad you asked. So reflow is part of the component in the assembly line of the critical rendering path, which is the way of how now yeah, how the browser transform HTML, CSS, and JavaScript, an image, into pixel on the screen, okay, through the bitmap, that kind of thing. But it passed through all of this series of phases. So you have now the HTML and CSS. You also have is now this is when the HTML, the DOM and the sys object model are created, and then is merged into something called the render tree that contains all the necessary data. But now the browser needs to actually know when all of these elements is going to live in the UI. In other words, how you're going to position these elements, and if this element position actually alter the geometry. And this is usually triggered by JavaScript, that now when you change a element via JavaScript, that alter is the style, for example, that change its position, or that trigger that change its position, or that trigger its position, or that trigger its position, that change its position of its geometry. Now it will pass through the layout phase, which is the way of how now the browser is calculate the positions and the position and the geometry of all of these elements, and then paint that for that. So this process, the style and the layout, because calculating this geometry and the positions is something that is CPU intense, okay, we can have now a more optimized pipeline where we only use specific CSS that talk to the paint and the composing phase, right? Which is what we have here. So instead of actually changing the positions or the geometry of an element, for example, if we're margin top or using width and height, instead of doing that, we just use this particularly inconvenient CSS class as a way to optimize now our pipeline here, right? So we effectively are creating is this layer stacking context, where now the GPU is gonna treat them particularly. So how now the browser, or how now the GPU treat this this CSS class, or how now the browser talk to the GPU? You may wonder. This is through the composition layers. So in all the browsers and these composition layers, you utilize is most of the time is CPU, right? But now with new browsers, at that particular layer, they use is now the CPU and the GPU. So the whole point of this is that by looking at the composition layers, which is the way of how now the browser create is this layer as a way to talk to the GPU, right? So because we have now something called the render object, which is something that is generated by the browser as a way to represent each one of those elements that have now a corresponding object on the render. But when you change now the normal flow of each one of them, you are effectively creating is a render layer. In other words, is the way of how now you're going to talk to the GPU through this particularly render layer, which of course, since this particular model is not optimal, what is doing the render layer, especially when you, for example, change the position of When you're using, for example, position relative and absolute, transforms, it is transparent, has CSS filters, corresponds to canvas element that has 3D WebLG context or an accelerate 2D context, correspond to the video elements. So this each one of those elements here in the CSS class actually creates a render layer, where when you change that, for example here you can actually barely see, but when you change the position of those elements, or when you move the position out of the normal flow of those elements, now the browser is creating this render layer. That's what we have here. It creates the initial elements here, and followed by all of these child nodes, which is create this render layer because you actually explicitly tell to do that, or you use, for example, a video HTML, that kind of thing. However, because having all of this node here and keep track of all of them is something that you sometimes is not efficient. Okay, so if you want to directly talk into the graphic layer to the browser's graphic APIs, this layer is when you use now 3D or perspective transform. So for example, layer is used by video, canvas, but 3D and 3D context. Okay, 3D and 2D context. So what is doing behind the scenes when you create now a context, we are creating is a graphic layer as well. Layer is used by video and canvas. Render layer has 3D or perspective transform. Layer uses CSS animations for its opacity. Animating WebKit transformations. Actually, you can see this because it's very okay. Layer use accelerator CSS filters. So when you're using filter, you are effectively creating is now a let me actually put this at test run. Let me actually put this at npm on def, npm run def. Let me actually I just want to put this at test run to see this. So for example, when you're using now a video or a canvas, right? Let's gonna use a basic video. So video here, and then you just want to use a demo video tag, right? Then you have a demo here. Exactly, but you just wanna exactly. There you go. That's exactly what I wanted to do. Point to that, but I think source. But this is pointing to the local. Yeah. Can I point to? Then you have something that I can use. Holy moly. Of course, it's not going to load this because anyway. You know what? Perplexity, bro. Jesus. Provide me an example of HTML video tag working. A working video tag. Yeah, but okay. Provide me an example of HTML video working tag. HTML video tag with a functional source, or with a real test source. Oh my god. Ew. I'm scared. Anyway, yeah, here we are. There you go. So this is the video. Before you're gonna complain about it, it's like, hey, what in the F is this? It's a video, bro. Okay, let's go to actually load this. This is supposed to render now that and say failed to compile. Expected okay. Yep. GSX syntax expect that. Now it's running, and there you got it. So okay, that's great. So the whole point of this is to see on the composite. Where's the composite? Yeah, what is the composite? Oh, wait a second. Yeah, this won't work here because it must be on Chrome. Okay. Scrolling. Security, performance, memory, performance, network. Yeah, it's like how you can actually see that.
Good at rendering
it on
nice and utilize by changing the size transformation, graphic layers.
Okay, layers. Yeah, because we barely use that. That's interesting. That's very, very, very interesting. How? That's very, very interesting. Workspace, experiment, ignore. How can I access to the layers? Right? Oh, okay. Yeah, how to access to layer. How to access to layers tab in Chrome. Yeah, how to access to layer tabs in Chrome. Command Shift P. Oh, okay, Command Shift P. Okay, Command Shift P. Show layers. That's right. Oh my god. Oh. It works. I'm not sure if Firefox. Show me now with Firefox. Okay, option command, option I. Okay, command option I. Okay, and here you say command option I, and here you say it's using the 3D view. A 3D view of layers. Using CSS overlays. Accessibility. Application. Redux components. And they oh my god, you're showing this component. Okay, but you are. It's a huge of context. Anyway. Oh my god. I mean, you can use context. All right. Generate image, that kind of thing. Yeah, show composite layer in that's done. Now it's like how to show composite layer in Firefox DevTools. Oh man. Okay, please avoid this. Access to performance tab, start recording, analyze composite layers. Oh, okay. In performance and analyze. Okay, but it's here. In graphics. But this is the profiler. No, my friend. No, I'm sorry. No. Let's make it simple. Simple, bro. Simple, and that is, yeah, simple, my friend. Chrome, this one. There you got it. Show that. That's it. So video tag actually create this. Layers. It's creating this one. It create, of course, a layer for the entire HTML element, as you can see here, for the entire document, and the other is for the video. So now you see is creating is this particularly layers, right? Slow scroll react in Paint. So the thing here is that memory estimate 5.4. Overlaps of the composite content. But as you can see, this is actually how many take that. So the entire size of this is 21 megabytes for the document, other for 5.4. He's allocating all of his resource to this. Similar for something called that hashtag 33. Not sure what is that. Another thing called that div size. But as you can see here, it is indeed creating that. I'm gonna put this as it is. So it's indeed creating that, so we don't lose our mind by looking at that. You know what I mean? So this actually work as intended. So video creates that. Canvas with 2D and 3D create now a graphic layer. CSS animation for reduce opacity, it also creates that. Let me see if this actually is what it is. So for example, if I say now, hey, let me put this another this and say, hey, opacity is calling a graphic layer. Okay, so you say, hey, let's go to find now an opacity here, opacity of 30, right? We're going to render now these elements here as it is. Okay. Interesting. Opacity doesn't create that. Okay. Oh, I mean, it's layers that use that. CSS animation for it is opacity. Oh, okay. Layer is used by video and canvas. Render layer has 3D or perspective transform CSS property. The layer uses a letter CSS filter, has a descending that is composite layer. Layer has a sibling with a lower C index for that. So, but the thing here is that layers is used by video and canvas, and layer uses. So, when we use, for example, now a transformation, okay, instead of opacity here you say, hey, now transform or transform, translate this to X, all right, which is that. I think that transform, not sure what that transform is actually doing there. Okay. But this is translate. Tailwind here. Transform. Transition. 3D has 3D or perspective transform. Perspective transform. Perspective. Well, actually I'm using that for this element, but it seems that doesn't work. So transform okay, hardware acceleration. Oh my god. Because you have explicitly have to tell that. And there's a transform GPU, and when you take a look now at the layer, of course it now include that. Exactly. This is quite interesting here. Very, very interesting. So the thing here is that let me, you can see, that's right. So the thing here is that now we have creating is this layer here, all right, which is actually also interesting. Canvas, create that layer, because canvas is taking all the available space as well as the sizing here, right? There's another other element, little element here. Yeah, there is another little element here, which is opacity. But as you can see, it's creating is all of these layers as it is, right? So this is the way of how you can now actually tell the browser, hey, for if you're gonna create a video tag, or not, if you're going to create is a video or a canvas for graphic layer, you're gonna create a video or a canvas or any of the CSS transformations, okay, perspective transform, I want you to use now is the graphic layer. That's something interesting. That's beautiful. That's beautiful because now what we really get into this video is yeah, what we really care about in this video is looking at the DOM API. So first, let's gonna take a look at this particular example here, like that. All right. There you got it. All right. Okay. Good. So, now that we are here, DOM API.
So what is the DOM API? So the DOM API is a
DOM API. Example, and this is browser rendering. Okay. And here we are with the DOM API. Okay. DOM and query. DOM and query.
set of methods that we can utilize to manipulate the DOM. And usually we don't use it directly because most of the libraries are handling the DOM mutations for us, for instance, React, Angular, or Vue. But there are cases where we actually need to use the DOM API. And one of that is when you're building some low-level library that works with virtualization or some DOM management. Also, it's used when you need to create some generic components that can be ported to any library or framework. It can be a video player or chart engine. And also, for instance, you are building your portfolio website and you want to minimize the blueprint of your application by not importing too many libraries. So this way you can just use the DOM API and your app will be lightweight. So this section will give us a quick refresher on how to use the DOM API. So first, let's overview the objects that are available to us. and how can we use the DOM API. So the first global object that we are all aware of is the window. The window is a globally accessible object, so you don't need to import anything. And the next one is the document. The document represents HTML element, basically the page that we are currently rendering. And the document can be accessed through the window or through directly by referencing this as a global object. Then we have some quick access links that we can use on the document. It's a body and a head, gives you us the body tag and head respectively. Now let's go through the class hierarchy. All the elements on the HTML page are represented by HTML element, but apparently the HTML element doesn't have any DOM API assigned to that. The DOM API is actually assigned to the element prototype. So why is that? Because the DOM API can actually work not with just HTML, so it can be also SVG element or XML-like things. That's why the DOM API lives on the element prototype instead of HTML element. And we also have the node. The DOM is a tree, and somehow we need to access the tree properties. So that's why we have a special class that's designed to represent a tree leaf, and this is the node. And we have exception, which is a text node, which basically extends the node class. The text node is used when we use any tag, when we need to wrap our text in an HTML element. So the browser needs to somehow represent the text that we place in our text. Then we have the HTML document, and HTML document is outlier here because it has the DOM API assigned to its prototype, but it extends the node. I don't know the reason why, but this is the exception in the whole hierarchy that we need to live with. And the next type in our text. Then we have the HTML document, and HTML document is outlier here because it has the DOM API assigned to its prototype, but it extends the node. I don't know the reason why, but this is the exception in the whole hierarchy. Needs to somehow represent the text that we place in our text. Then we have the HTML document, and HTML document is outlier here because it has the DOM API assigned to its prototype, but it extends the node. I don't know the reason why, but this is the exception in the whole hierarchy that we need to live with. And the next one is the window. Basically, the window has an instance of HTML document, and it doesn't have any interesting properties on its prototype, so it represents the browser viewport. Query methods. Let's now understand how the browser queries elements on a page, how the DOM API queries the elements. So let's start with the most simple method, which is getElementById. So when the browser reads the page, it constructs the hash map of the elements. So it reads the ID, and then it basically builds the cache where the ID is assigned to some HTML reference. So this means that when we try to get the element by ID, the time complexity and read cost is just 0.1, because this is just basically accessing the object by its key. The situation is slightly different when it comes to get elements by class name. So to get the elements by the class name, we need to actually traverse the whole tree. And the way the browser traverses the tree, it's used the DFS approach. So it basically goes through the elements and finds all the elements on the page with the class text. So DFS approach. So it basically goes through the elements and finds all the elements on the page with the class text. So, and the time complexity for this is linear. So we need to go through all elements in the worst case. But you see there is a star here. This is because the browser is quite smart and it utilizes the hash map when you try to query things. So the first query will take some time, but if you execute the same query next time, the browser it will be almost immediately because the browser utilizes the caching mechanism. And one thing about this method is also it returns the HTML collection. And an HTML collection is the special, actually legacy collection, which you this quite safe get object by its key.
Okay.
The situation is slightly different when it comes to get elements by class name. So to get the elements by the class name, we need to actually traverse the whole tree. And the way the browser traverses the tree, it's used the DFS approach. So it basically goes through the elements and finds all the elements on the page with the class text. So, and the time complexity for this is linear, so we need to go through all elements in the worst case. But you see there is a star here. This is because the browser is quite smart and it utilizes the hash map when you try to query things. So the first query will take some time, but if you execute the same query next time, the browser it will be almost immediately, because browser utilizes the caching mechanism. And one thing about this method is also it returns the HTML collection. And an HTML collection is the special, actually legacy collection, which has one interesting characteristic: it's live. So this means that if we modify the DOM tree and, for instance, remove one element from the DOM, this will be reflected on our HTML collection. So, and that's why the read cost of the HTML collection is big O of n, because every time we need to read a single element, the browser will parse the tree again to verify its position. So this is a disadvantage of this thing. But on the other hand, the memory cost is low because the browser doesn't need to clone any objects. It just takes the already existing references. So you can utilize the HTML collection when you need to be low, like when you're low on memory, you need to use as less memory as possible. Okay, the same way works the get element by tag name. So there is no difference at all. It's just like it allows us to query things by the tag. So the query selector works slightly different. So it utilizes the CSS selector. So the time complexity depends on the selector that we use. So we always pay some tax on compiling the selector. So this means that the more complex selector you have, the more time it takes to compile it for CSS. And so the read access and the memory cost is big O of 1 because we're just returning the single element. And the querying mechanism, when we try to use the class names or the tags, it's the same as the DFS. If we use the ID, then we're going to convert the statement to get element by ID instead. So one interesting thing about the query selector, and this is the query selector O, is because it returns a node list. The node list is another type of collection, but it's not live. It's just basically the copy of the elements. So what the browser does is just copies the HTML objects, and this means that we pay additional memory cost when we do the querying. So it's not advisable to query too many things because you may end up having the memory spike. But the read access is O1 because you're just accessing the object directly from the array instead of traversing the tree again by maintaining the live collection. And the querying mechanism is the same, DFS plus hashmap. Quick summary. So the get elements by ID provide the best performance, but because the browser builds the cache, but you need to make sure that you utilize the ID space correctly. So it's basically anti-pattern to you to rely on IDs too much, because the ID namespace is shared across your multiple components, and just make sure that you don't overuse IDs in your app. The get elements by class name or get elements by tag name provide a low memory overhead because it returns the live collection with just references to existing objects. But because the read access is high, so you need to make sure that you utilize this collection right. Because if you're going to loop for this collection, yes, it will convert to quadratic time. So and we don't want to do that in our app on the large set of elements. The query selector has slightly worse performance than get element by ID, but the browser itself heavily optimize any CSS selectors. So in different browsers, you may get different results, but on average, it's very close actually to get element by ID. But the elements that are returned from this query do not represent the live collection. So if you remove the element from the DOM tree, you may end up having the stale element in your collection. Yeah, the same applies to the query selector all, but it also, because it copies all the elements, you don't want to query too many elements with this method.
Could you clarify the difference between the time complexity of querying versus the read cost?
Yeah, okay. So if we'll go back to get elements by tag name, for instance. So the time complexity it takes to go through the elements to find all the elements that we are looking for is big O of n, because we need to go through all elements in the worst case. But the read cost is also big O of n because we maintain the live collection. And when we maintain a live collection, this means the browser needs to verify that the element exists in the DOM tree. So every time you're trying to access this live collection, the browser queries the elements again to verify that the element's still present. That's why it can result to the time complexity being, in the worst case, we'll need to parse all elements again.
Is there a reason the query selector all returns the non-live element list compared to this one, for example, comparing or returning the live?
So the live collection is actually a legacy one. It's not recommended to use for normal cases. And I guess the query selector returns non-live collection because we needed to have some alternative. The live collection has more drawbacks, and if not used wisely, can lead to more issues. But in our application development, we don't really need to manage the live collections. And for most of the developers, the query selector is the better go because it doesn't have the expensive read access.
Why would query selector all impact memory? We're returning references to nodes which already exist in the DOM.
Not exactly. We actually return the copies of basically the browser creates a new object with the same values and the copies, and when you change the properties of this object, it will impact the original object, but it's still, we have two separate objects basically with the same properties, and they are connected with each other through the proxy mechanism. So it's a slightly different. When we use the live collection, we actually guarantee we can actually reuse the real reference to the object instead.
When you're saying that the cache would make things faster next time, are you always sure about that because class names can be dynamic?
So you can't control that because it's up to the browser engine. Like, it's up to develop it. The same query methods can behave differently in Safari or Chrome, depending on how developers optimize that. For instance, Safari browser uses the WebAssembly compilation for the native selectors, while the Chrome doesn't use that because they find that the performance of existing query selectors is fine on average. So you can guarantee the same results, and it's up to the engine. So the logic of caching the element, the class, the query selector is quite complex, and yeah, no guarantee. Let's move on to performance best practices. The first and the most obvious one, and the one overlooked the most, is that we can actually improve the performance of querying by simplifying the selector. So each time you use the complex selector, the CSS compiler needs to transpile this, and it takes more time. So you pay extra tax on using the complex selectors. So you may notice that it's not significant. So you may pay like 5 milliseconds on the query to compile the selector, but all these things are accumulating. So if you do hundreds of
with a
queries,
needle
so
in
it will
React.
result maybe to 50 milliseconds on average in the delay. So, but if we combine all possible optimizations with this one, the results can be quite significant. Although the IDs is not the best practice, you still can utilize IDs for the core container when, for instance, you need to query the element from the very large tree. So if we have some DOM tree that has 10,000 elements, if you query from HTML, then you need to go through 10,000 elements on the first query. But if you, for instance, could select this section with an ID, and then you know that this operation should be repeated multiple times, then you can just provide an query from this section, and it will be just one operation. So next section is adding, removing elements. And before we jump to that, any questions so far?
So you talked about these, like understanding the differences between these methods being useful if you were going to build something more low level. If you're working on something that is using a framework like React or Angular, are there recommendations you would make for improving performance or like knowing what their methods are using under the hood? Or do you just kind of trust that the library authors have spent a lot of time thinking about?
Yeah, when you utilize any library that manages the DOM for you, you just rely on this library. The only way you can possibly think, you may use your the DOM API within some effects in the React when you need to query things. This is the place where you could optimize potentially, but trying to optimize a React is not a good idea because it's quite complex inside.
Is the cost of CSS only during compile time? Wouldn't the runtime of complex selectors also be add-on performance?
No, actually,
CSS only during compile.
But trying to optimize a React is not a good idea because it's quite complex inside.
Is the cost of CSS only during compile time? Wouldn't the runtime of complex selectors also be add-on performance?
No, actually,
Wait, what?
Of CSS only during compile time? Wouldn't the runtime of complex selectors also be add-on performance?
No, actually, you compile this. First, you compile your styles in CSS. This compiled when you initiate the page. But when you execute the JavaScript with some query selector, this is dynamic selector. This means it should be compiled in runtime.
In runtime.
So you pay the cost every time you execute that. Okay? So let's now understand how we can add or remove elements. And when it comes to adding or removing, every method is bad. So basically, we don't have a good. So the performance impact is always significant. So there's no good method to insert data because every time we modify the DOM, it triggers the reflow. So in our application, we want to minimize the reflow operation, and so but there are a few methods that are particularly impact the performance. The first one is inner HTML. So when you use the inner HTML, you basically set the HTML of the element. The browser needs to involve the HTML parser to compile your HTML again, to do the full reflow, validate your HTML, and so on. So you pay the cost of the parsing. Same applies to insert a JSON HTML. Because we use the raw HTML, the browser still needs to parse that. But if you need to modify the DOM, make sure that you don't utilize the inner HTML too often. It's okay to use this once per initialization, but if you expect it to insert elements dynamically, then it's better to utilize the insert a JSON element or append child because it takes the compiled HTML object already and just renders this on a DOM. And we can see how it works. So the method is pretty flexible because it accepts the position where we can insert the element. The first one is before begin, which basically insert the element before the target element. So we can try to insert that and the element is inserted. So the after begin will give you the first child position, while the before end will render element as a last child. And after end will give you the position right after the target element. So this method is very flexible and can be used almost anywhere. Then how to target element. So this method is very flexible and can be used almost anywhere. And after end will give you the position right after the target element. So this method is very flexible and can be used almost anywhere. Then how do we remove elements? So removing elements can be done through the remove method. Basically, we need to have a reference to the object, and we can also reset the whole HTML by setting the empty string. We're going to do some live coding, very simple exercise. So we have some HTML template that we need to utilize, and we have our create card component function. So we need to implement the function that takes the title and the body, this is the string variables, and sets it to the h3 tag and card body content. There are multiple ways how can you implement this, but let's see what we can do here. And here we call this function, so this function should return HTML element, and then we append this element to the container. So to start with exercise, check out the repository. I hope you will have the link to a repository in the chat, or you can also click on the slides and open the folder begin and open the file index.html. We don't need any compiler or complex setup. It will be enough just to work with the HTML, use your favorite editor. And now I'm going to switch to the code. So I opened the index.html. So here we have our container, then we have our HTML, which is right now stored as a string, and also we have our HTML element, the function that creates our cart element. Right now it's empty, so our goal will be to implement this. So what can we do here? We could potentially just say, for instance, container, and then set the inner HTML. But then we would have to work with the HTML with the string directly, and representing the HTML as a string is not the best way to do things. So we want to have some kind of reusable way how can we represent the templates. So, and apparently in HTML we have the special tag called template. So we can remove this line. And in the head, I'm going to use the template tag. So what this template does, it basically stores your HTML in the lightweight object in memory. So this content is not queryable by any DOM API. So any external scripts will not be able to access this content. So it's also not rendered on the final render tree. So if your user tries to traverse the DOM tree, they will not be able to see that this template is utilized. So it's kind of a lightweight representation of our card. So we added the card template into the template tag, and we also assigned the ID. So the content of the template is not queryable, but the template is. So we need to clone the content of the template. So let's let's first query the template. So we can do document get element by ID. And then we use our card template. So now we have the reference to the card template. Let's clone the content. As we know, the templates use the fragment, so we need to clone the content of the fragment through the special method that I'm going to show now. So we're gonna access the template, and the template has the property called content. So the content gives us the fragment that we need to work with. So then I'm going to use the clone node, and I'm providing the true flag to do the deep clone, and then I use the first element child that will return me the article. So by default, first it will return the fragment, but we need to access this element. And this element is the element, and that's why we use the first element child. So now we have our article. We want to update the article content. So we need to set the card title and the card body content. So let's query that. So let's call it card title and card body. And then we use the document query selector all. And then we're providing two selectors. The first one is the card title. Then we need to pass the card body content class. So now we selected two elements, card title and the card body, and now we want to update the text content of these elements. So we use the text content property and then assign title. Then we need to use card body and then assign text content to the body variable. Okay, now we return the card, and if we run this example, so now we're creating a new card element, and then we're returning this card element from the create card component function, assign some random text, and if we run the browser, and then we're returning this card element from the create card component function, assign some random text, and if we run the browser, we see that this doesn't work, and let's see why. And apparently we're trying to set the text content so the property undefined. So probably we have a mistake in how we query things. Yeah, so we don't need to query the document, we need to query card. So, and if we fix that, yeah, now we have our card rendered and all elements set. And this is it for the first exercise. Okay, let's have a quick look of how could we potentially solve that. The first solution would involve
complex elements.
Treating the article as a string. So we could create the placeholders within the context and just replace it with the replace function, but this means we would need to work with a string. And then we could append the content using the inner HTML, but this is not the best way because we'll have to parse the content here in inner HTML. And if we want to repeat this operation, then it's not the most efficient way. So what we did is we just used the document fragment, which is the lightweight representation of HTML element. And since it's shielded from causing the reflow, we can do whatever we want in memory. So it can also be reused many times, and it says isolated from the queries. And yeah, we utilize it to keep our markup component in HTML, which is a very natural place where we should keep such things. And then we just updated our function and the solutions, and here is the final solution. Before we jump to the next section, do we have any question?
Can you just explain again briefly why doing it that way doesn't trigger reflow?
Yeah. So when you modify the fragment, it's not within the DOM tree. It's actually just in memory. So when you update any properties, so it doesn't trigger any reflow. So if you could potentially have the element in the DOM tree.
So it's like, okay, a good example of this is like, oh my god. So it's like a secret pocket that you can have, pretty much like use ref. You can think of this template as a secret pocket that you put things in there that is not Reflow aware of this. You know what I mean? Okay.
And you would need to, and you start updating the elements of the properties of this element. Then this would cause reflow because the element already in a DOM tree. But since it's and you start updating the elements of the properties of this element, then this would cause reflow because the element already in a DOM tree. But since it's in memory, yeah, we can do any operations and it's disconnected from the main DOM tree. The only thing that counts the reflow is when we use append child. So the DOM API is actually pretty simple. It has some limited set of methods that we can utilize, and it's very useful if we're trying to build some low-level things. But we need to think about the caveats that the DOM API has. So for instance, make sure that you utilize the HTML live collection wisely. So don't query too many elements, and then don't try to read the HTML live collection, because it will result to collection wisely. So don't query too many elements, and then don't try to read the HTML live collection, because it will result to quadratic time. For most of the cases, the query selector has a good performance, and you can just utilize it almost everywhere. So for rare cases when you really need to have the live collection, make sure that you work with a small subset of data to reduce any performance impact.
God damn.
So the next section.
Jesus. Okay. That'll be all for this video. Take care. Bye bye.